Hey guys, so we're going to go ahead and get started on the Algebra 2 notes. And this is the Unit 1, Linear Equations and Functions. So the first thing that you're going to learn about is graphing horizontal and vertical lines. And if you recall from Algebra 1, when you're graphing horizontal and vertical lines and writing the equation, a way to remember how to write the equation is using the term HOI and VUX, where HOI stands for horizontal line, zero slope, and y equals. So you write horizontal lines y equals, and VUX is a vertical line, an undefined slope, and x equals. So what you're going to do is you're going to plot the following sets of points and then write the equation of the line. It's either going to be a horizontal or vertical line, and you'll see what the pattern is here. So in the first one, if you just look at the sets of ordered pairs, you'll notice that the pattern that is here is that all of the x's are the same value. All of the x's are -2. So let's go ahead and plot these points. So you're going to plot -2, -3 is right here. -2, -1 is right here. -2, oh, sorry. -2, -1 is right here. -2, 2 is right here. And -2, 5 is right here. So if I make a line out of that, I can easily tell that that is a vertical line. So if you recall that VUX, vertical line, when I go to write this vertical line, I'm going to say that x equals -2. That's how I would write the vertical line, x equals. And all of the x's are in common, so that makes sense to how you would write that equation. So if you glance at the next problem, notice that the part that they all have in common now is that the y's are all 3. So right off the back, we are able to write this equation. We know it's going to be a horizontal line at y equals 3, and then you can plot the points to prove that. So you've got -2, 3 is right here, 0, 3 is right here, 2, 3 right here, and 4, 3 is right here. So you have the horizontal line that goes across there, and we write that as y equals 3. So when you're looking at functions, a function is a relation in which each value in the domain has only one value in the range. What that means is when you're looking at a function like a line, the x's can't repeat. That's an important piece about a function. And the graph must pass the vertical line test. And I don't know if you recall that from Algebra 1 as well, but basically when you have a vertical line that goes across the graph, if it only touches your graph once, then it is a function. And then we also are going to come across what is called function notation right here. And how you would say this is f of x is equal to 2x. So f is the name of the function. X tells you what is being input into the function, so what numbers might be input into the function. And then the result tells you what the function actually does. So in this case, the function is actually multiplying any number that represents x or that x represents times 2. Okay, so this is just important pieces of information when you're looking at functions. So if we look at the next set of notes, it's graphing linear functions and tables for linear functions. So when we are graphing a linear function, that's also known as a line, there are a couple different ways that we can do it. The first method is by coming up with a table of values and then plotting those points and connecting the lines. So a table of values, usually what we use for a table of values are we plug in numbers for x, and we usually say -1, 0, 1, 2 are usually our set of values. And all you're going to do is you're going to plug those numbers into the equation in order to get what f of x is going to equal to for each of the ordered pairs that you're creating. So for x is -1, you've got -1/2 times -1 is +1/2 plus 3. So my first ordered pair is going to be -1 and 3.5. Okay, if I plug in 0, then the -1/2 goes away, plus 3 more, and your answer is going to be 3 there. If I plug in 1, then I've got -1/2 plus 3, which take away half from 3, and you've got 2.5. So the next one is 2.5 as a plotting point. And then if I plug in 2 into the equation, then I get an answer of half. -1/2 times 2 is -1 plus 3 is 2. So my answer there would be 2, 2. And then you're just going to plot those points. So you've got -1 and +3.5 is about here. 0, 3 is about here. 1, 2.5 is here. And 2, 2 is here. And then you're going to draw the line to the best of your ability. So that is plotting using a table of values. The next form of plotting, I think, is the easiest way of plotting a line, and something in a way that you may have been taught in Algebra 1, where you first plot the y-intercept, which is the b in your equation. So remember, your equation is always y equals mx plus b, okay? So your first job is to plot the y-intercept, which in this case is at -1, and we're going to plot that right on the y-axis. So we're going to plot -1 right on the y-axis. And then you use the slope to plot additional points. So the slope in the equation is the m in the equation, and our m happens to be 2. But remember, slope stands for rise over run. So we've got m is 2 over 1 because it is a whole number, and any whole number is always over 1. And remember, that stands for rise. So since it's positive, we're going to go up 2. And since it's positive on the bottom, we're going to go right 1. So rise over run. Remember, slope is rise over run. So from that point we plotted at -1, we're going to go up 2, right 1, and we're going to plot another point, and then you can make your line. So I think that this is an easier way to graph a line. You can do either of the two methods, but I think that this way is a lot faster. So reminders. Reminders that the equation of a linear line is written y equals mx plus b, where m is the slope and b is the y-intercept. And the y-intercept is plotted right on the y-axis. Another reminder are the types of slopes that there are for lines. So a positive slope goes up from left to right. So a positive slope goes this. So all the time, whenever you're looking at slopes, you're always looking from left to right, like you are reading. So if you look at that, that's a positive slope if it's going up. If it's going down from left to right, that's a negative slope. If it's straight across a horizontal line, that's a 0 slope. And if it's straight up and down, then there's no slope at all, and that's considered an undefined slope. Okay. If we move on here to the last set of notes, we are asked to identify linear equations and functions here. So when we're identifying linear equations and functions, we have to determine whether it is in one of these three forms. So we just talked about that a linear function is in the form y equals mx plus b if it is a slanted line, okay? And we also talked about graphing vertical and horizontal lines, which are two linear functions. They are both pictures of lines. And remember, a horizontal line is y equals some number, and a vertical line is x equals some number. So knowing that those are the three types of linear functions, we can now look at our equations and see if they match any of those. And if they do, then the equation is linear. And if they don't, the equation is not. So the first one is in y equals mx plus b because it says y equals x plus 9. That's in y equals mx plus b. So yes, this is a linear equation. In the next one, we notice that we have x to the third power. That's not one of our options for a linear equation, so that equation is not linear. Again, look in the next one, we have x to a second power. That's not one of our linear equations. And in this last one, we have x that's raised to a power, which again is not one of the linear equations. And then it says, which of the following ordered pairs represent a linear function? So when you're giving tables of ordered pairs, what you need to look at is the change in y. And what I mean by that is you have to look at what happens to the y from each point to the next point. So in this one, to get from -4 to -5, we subtracted 1. To get from -5 to -6, we subtracted 1. But to get from -6 to -4, we added 2. Since there was a change in the ordered pairs and they weren't all the same, the change in y's were not all the same, then this is not a linear function. In the next example, we have that the change in y from 5 to 10 is +5. The change in y from 10 to 15 is +5. And the change in y from 15 to 20 is +5. So yes, this would be considered a linear function because the change in y is the same. Okay? All right, so try these topics out in ALEX, and as always, let me know if you have any questions. Good luck.